Hello and welcome to the PEPS Opticam Classic Quick Start Guide. In this example, we will be creating a simple program from a 2D drawing. After you have imported your drawing in, the first step is to create a profile figure. We will go to the Preparation menu and Profile Figure. The profile figure consists of three main parts: the start hole, the on profile, and then lines and arcs. First thing that I will do is click on my select button, which is also the double greater than signs. And then I will go to my drawing and select my start hole location. Next, I will select a lead on position, also known as an on profile position. And then last, I will go down to the big bar at the bottom and select my lines and arcs. There are a couple of ways that you can select your lines and arcs on the drawing. You can either window the whole thing, or we recommend that you use our chain or link function. This way it will link each segment of your drawing piece by piece. So if there is a gap or some sort of a break in the geometry, it will stop there and it will be easier for you to spot and then edit or fix your drawing. Once you are done with a function, make sure that we go and click on the End command. Okay. After your figure has been created, your Create Figure dialog will pop up again just in case you have more figures to create. For this example, we only have one figure, so we will click Done. And then next, our next step will be to create our machining. I'll go to my machining menu and then select from the three machining functions that we have here: standard profile, collar, and ruled surface. For this example, we will select standard profile. Select my programming units. And then our workpiece or operation sequence dialog will pop up. This is because we do not have one already created, so this is the first thing that pops up. On the first page here, we have our billet page. So this page, you can create a billet, which is also just a representation of the block that you are going to cut this shape out of. We do not have one already created here, so we will click on New and create one for this example. You do not need to create a billet to create your program, but it's nice to have. So you have different type of billets that you can create: rectangular, circular, from lines and arcs, or from a figure. So depending on which type of billet you select, the parameters will change to define the shape of that billet. For this example, we will use rectangular, and I will select the XY minimum and XY maximum corners of my block. So I will select again, click on the select button, and then drag my mouse cursor to this bottom left corner for my XY minimum, and then the top right here for my XY maximum. I will also need to type in a thickness for my material, and if my block is sitting on some sort of a fixture above the table, I can put in that B height as well. For this example, our billet will be sitting on the table at Z0. So once I'm done with this, I'll click OK. And then we can move on to our next page. So output file. On the output file page, the first item on here is to name your NC file. So right now it's using the same name as my program. The next dialog box here is for your NC directory. This is where your NC code will post to. You have several options on here. The first one is the default PEPS version 2023 is the current version I'm on right now, but depending on whatever version you have, it will go to that folder. You can select the current job directory where your VDM file is saved and it will post there. Or if you have a user specified directory, you can click on this and then browse to that location. Next, we go to our from position and reference position. We need to set these. The from position is where your nozzles drop in, and the reference position is your origin or your 0. For this example, I will leave everything at 0, 0. My datum is using a G54 while I'm using my Makino machine here. And then down here at the bottom, your secondary and reference plane carried over from when I created my billet. Right? If you did not create a billet, you will have to go in here and manually put in a secondary plane. Okay? Nozzle heights over here are only for simulation purposes. These heights do not have anything to do with your nozzle heights at the machine. Okay? So after we've filled out and checked the numbers on the output file page, we will move to the technology page. On the technology page, this differs depending on what machine or what post you are using. For the Makino, I am able to select technology inside of the PEPS Opticam software. So on this page, I am able to select the material I'm cutting as well as the wire that I'm using at the machine. For this example, I will be using 10 thou brass wire. Okay, and then the last two pages here are very specific to what you are doing. For the most part, we leave these as the defaults. We will use the PEPS sequence strategy, and then on the very last page, we can turn on wire is threaded. This is only if you are manually threading your wires, and you turn off the auto wire controls inside of the settings. After you have finished all 5 pages, go ahead and click OK, and then your actual machining dialog will pop up. The first thing that we'll do here on the standard profile machining dialog is to select the figures that we are going to cut. Keep in mind, if you have multiple figures, the order that you select your figures in is the order that they will cut in. This example only has one figure, so we will select that and then click in command. Next, we will select the technology for this program. I'll go down to select technology. Once again, depending on the post or machine you're programming for, the select technology dialog will be slightly different. Okay. For this one, for the Makino, I will be selecting my nozzle characteristics. I'm going to go with both the way high precision, and then I need to also make sure that I select how many number of passes do I want to do. Right, so I'll go down to machining process and I will select finish 10. This has 3 passes, a rough and 2 skim passes. So right now I'll go all the way down to load technology and then go to setup. In my setup, I am able to see the offsets that were loaded in from the technology database. Right. So here on this first page of the cutting setup, I have my cut controls. All right. So from here, I have a lot of different options in here I can use depending on what I need to modify if I am running into issues with some undercutting or some funky cuts on my program. All right. So here you also have the option of using reverse cutting. Okay. So this will cut in the opposite direction every other pass. Okay. You're also able to add additional clearance depending on what number you put in here, a positive or a negative number. This will add to your offset to either leave more material on or cut more material off. Okay. All right, so the next page is our tagging page. This is where we are able to put in a distance for our tag stop to hold on our slug before it gets cut off. And then we can also manipulate the lead off distance here. Okay. At the very bottom, we have our different tag removal methods. Okay. So for this example, we will be using the first tag removal method. This is basically just telling the software when you want to cut the tag off. Okay. So on this program, we will be using the first option, which is stop, then cut tags on the first cut. Okay. And then we can continue to our third page. Our lead page, this is how our wire is leading onto the profile, and then also how our wire is leading off of the profile. So a lot of different options in here depending on what you want your wire to do. Okay. And then last, we have our offset. Offset page right here is where you can change the direction of your cut, as well as you can also manually tell it what side of the profile you want to cut on. Okay. All of these are fine for this example, so I will go ahead and click on OK. So right back to our standard profile dialog now. On this example, we will not be adding any angles or any tapers, so I will also click OK again. So once you have clicked OK, when I rotate my drawing, I now have these green and purple lines. Green and pink lines, maybe? All right, these represent our wireframe NC. Okay, the wireframe NC here is our machining, part of our machining. So anywhere you see these green lines, this is where our nozzles will synchronize at the upper and lower parts of our block. Okay, so after you have done this, you are almost done programming this part. So all you have to do now is post your code, but before that, we will run our simulation. Okay, for this one, I will make sure that I'm running my standard simulation. That way, I can see if a slug is being dropped, and I can see which direction I can drop my slug. I'll go ahead and press play here. Start standard simulation. Once your simulation window pops up, we are able to take a look at what we programmed. Okay. For more information on setting up your simulation or setting your simulation settings, we have a separate video for that. Okay. For this one, I'll go ahead and press run. You can see here is our first pass, our rough pass. All right. So here it stopped at our optional stop command where our tag is. If I press play, it will cut our tag and drop our slug. And there we are. So now we have two different pieces. If I wanted to, I can also go to my bottom right hand corner here in the measure window right here, and I will be able to test which direction the slug can be dropped in. So you can see here we are able to test this in the Z positive and Z negative direction. So I'll go ahead and test this in the Z positive direction. There we are. If that looks good, I can also tell it to remove this slug and then continue with my simulation. Okay. So reverse cutting for the second pass, and then our third pass. Okay, so once you're satisfied with that simulation, we can just close this out. And now we will go and post our code. You can post-process your code in several different locations. The first location that you can do this from is from your File menu. When I click on this, you can scroll down to Post-Process. You can also go to your Utilities menu and post-process from there, or your quick icons at the very top of the screen. You can also click Post-Process from there. I'll go ahead and click on that one. After you have post-processed your code, an Edit NC Data dialog will pop up. In this dialog, you're able to copy your code to any destination you need to. All you have to go to is your options and select that destination or browse to that destination. If you want to preview your code, you can select on the second icon right here. Okay, so you can see here is our code, our output for our 3 offsets or 3 passes, right? Our call up for the first pass technology, our stop for our tag cut, and then the call out for our second pass technology, our skim pass, and then for our third pass. And once you're done with that, that's it. You send the code to the machine. Hope this video was helpful. It was just a quick video of our first example in the Quick Start Guide series. Thank you.